This factory specializes in bending steel pipe, which is manufactured in straight lengths. A piece of pipe is typically 12 meters long and weighs up to 20 tons. So workers use a crane to move it from one operation to the next. The first stop is a blasting machine that cleans the pipe. To heat and bend properly, the surface must be clean and uniform. But pipe usually arrives at the plant dirty and wearing a coat of varnish to prevent rusting during transport and storage. The blasting machine shoots grains of steel at high pressure for about an hour. The pipe exits with its surface now clean and smooth. From the blaster, it's onto the bender, which heats the pipe to about 1000 degrees Celsius, then makes the bend. A technician installs the induction heating coil. Induction heating allows greater temperature control, which is key to preserving the quality of the steel. The coil doesn't actually touch the pipe because that would cause a short circuit. Next, they clamp a pivoting arm to one end of the pipe, then power up the coil. This generates a magnetic field that produces intense heat. Cold water jets confine it to the target area. As a technician monitors and measures, the arm pulls the pipe through the heating coil at a specific speed, curving the softened steel to the same angle. Water cools the pipe at a controlled rate, a process called quenching. They must control heating and cooling precisely, otherwise the steel will weaken. Once the pipe exits the bender, workers verify the angle again. They also verify the pipe's dimensions to make sure the bending process didn't distort them. Now they cut off the straight ends, leaving just the curved portion. Next, the pipes go into a furnace for tempering, a 10-hour reheating and cooling cycle. This relieves stress in the steel that bending created. After tempering, pipes designed to go underwater go through a second quenching. This gives the steel the right properties to withstand deep seawater pressure. Then, using an ultrasonic gauge, workers measure the thickness of the pipe walls, which changes with bending. After another trip through the blast cleaner, workers apply a liquid that highlights even the most minute surface cracks that bending can induce. If they find cracks, they scrap the pipe. But defects are rare because the factory first performs test bends on sample pieces of pipe, then subjects those samples to a battery of tests. The lab measures dimensions and wall thickness, then tests how much weight the sample can support before collapsing, and how much stretching it can withstand before snapping. Back on the factory floor, the pipe goes through another blasting. Then workers heat it and spray on a protective coating that prevents corrosion. It melds to the hot pipe. Once the pipe cools, they stencil on technical specifications. Then these pipe bends go off to join their straight counterparts.